We want to demonstrate practical the way it should be done. Part 6, equation of uniformly accelerated motion. These three equations of motion we want to prove now is the basic principles or equations which we use in mechanics to calculate final velocity, to calculate distance traveled by car, buses, train, to calculate the time taken by these buses, cars, and train, and the rest of them. Not only that, to calculate the average velocity and the rest of them. We are making use of these to represent the car. These are the 4 tires. We hang it here, so it will move in a specific direction from east to west. So this is the picture of the car. Now, suppose a car, this car starts from rest. Rest is the beginning or 0 point with an initial velocity. We use U to represent initial velocity. Initial velocity means velocity at the beginning of the journey. It accelerates, that is, it moves at rate of 8 meter per second square in a given time t in second. It starts from here and reach this initial velocity and reach the final velocity in a given time t. There will be an increase in velocity as the car moves from here to here. There will be an increase in velocity. The product of the acceleration and time will give us that increase in velocity. So the final velocity here will be given by the initial velocity and the product of acceleration and time. This is the first equation of motion. Now let's go to second equation of motion. Second equation of uniformly accelerated motion. Let us use S B to represent the distance covered in a time t, with the initial and final velocity given by U and V respectively. Like if you want to find the average age of 2 children, U for Umar, V for Victoria. If Umar is 10 years old and Victoria is 12 years old, we had 10 plus 12 and divided by 2. 22 divided by 2 will give us 11. The same thing when you want to find the average of 2 velocity. So average velocity will be given by V is equal to U plus V all over 2. Now, the distance covered by this car will be given by distance covered is equal to average velocity times time. Average velocity times time. We use x to represent distance covered, U plus V to represent average velocity, and T to represent time. From first equation of motion, equation of motion, which is V is equal to U plus AT, as this equation will become, we are going to substitute V is equal to U plus AT. Anywhere we see V, we are going to replace it with U plus AT. Therefore, this equation will become S will become U plus U plus AT over 2 multiplied by T. This S is this U is this, plus V is equal to U plus AT. This 2 is this, multiplied by T. Now, this one will now give us S is equal to U plus U is equal to 2U plus AT all over 2, bracket open and close, T. Both value in the numerator, 2U and AT. This denominator belongs to both of them. So we have 2U all over 2 plus AT all over 2 multiplied by T. These two will cancel these two. We now have U plus AT all over 2 times T. Open the brackets. U times T will give us UT, AT times T, AT squared over 2. So X is equal to UT plus AT squared all over 2 is the second equation of motion. This one will give us this is the second equation of motion.